1.2 natural numbers and sequences. The homework problems will be problems 1 through 5. One is 2 plus 1 more is 3, and then 1 plus 1 plus 1 is 3 plus 1 more is 4, and so on. So natural numbers are known as counting numbers. Okay, definitions. Is double R looking symbol to the first with a 1 in it is a set of real numbers. Well, normally when we symbolize this with the real numbers, we don't put the 1 there. It's implied, but by definition, it's R with a 1 superscript. And here we have R with a 2 superscript is a set of ordered pairs of real numbers. So like x1, y1, x2, y2, x to the n, y to the n. So we won't get a whole lot of that, but it does show up once in a while. And then R with a superscript with a 3 in it is a set of word triplets, and that's on the x, y, and z axes. So you get x1, y1, z1, x1, y2, z2, x to the n, dot, 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 x to the n, y to the n, z to the n. So it keeps going on depending on what n is. Okay, R with superscript 2 is a relation from R from real numbers to real numbers. Is a set of ordered pairs of real numbers. So the x values are real numbers and the y values are real numbers. Well, let's go back over what are real numbers. Well, first we have n, which are natural numbers. And those are counting numbers, 1, 2, 3. And then you have whole numbers. And whole numbers are nothing more than natural numbers plus 0. So 0, 1, 2, 3, so on. So that's the only difference between a whole number and a natural number. So basically, we use W and then we put a little extra line in there to distinguish that for a whole number set with just a regular letter W. Now, same thing here. This symbolizes the natural number set, which distinguishes it from just any n. And then we have integers, and that's symbolized with a Z, and then we extend that out like that, and that's integers. And that's basically negative and positive whole numbers. And then we have rational numbers. And that's basically fractions, where it's an integer over an integer, and the decimal, where you can take the fraction and convert it to a decimal, where the decimal terminates, like 1/2 equals to 0.5, or repeats. such as 1/3, 0.333333 repeating. Well, since R is taken up for the rational numbers, we use Q. Since R is taken up for the real numbers, we use Q like in quotient for the rational numbers. That's the way to remember that. And then irrational is symbolized with an H looking symbol, and those do not repeat and do not terminate as decimals. Well, some examples of irrationals are square roots, like that don't simplify completely, like square root of 2. Pi is irrational, 3.14159, and it goes on forever. E, 2.71, that goes on forever. Those are examples of irrational numbers. Well, all of these together are in the real number set. Well, what is not in the real number set? Imaginary and so imaginary is not, such as I, or well, what is that? That's basically a negative inside an even radical. So imaginary are not real, part of the real number set. So imaginary is not real. Everything else is considered real. Okay, so continuing on with that. Relation is relation from R, real number, to a real number. It's a set of ordered pairs of real numbers. When we say R squared relation from R to R, it's meaning X is the input, Y is the output. Real numbers go in, real numbers go out of the function. So the domains all real number has all real numbers in it, and the range has all real numbers in it. And so we have here domain of our ordered pairs, a set of real numbers consisting of all first elements in the ordered pairs. In other words, the X values. The range is a set of all second elements, or Y terms, in the ordered pairs, and they are also in set of all real numbers. A function f from R real numbers going in to real numbers going out, real numbers x going in to real numbers y going out, are a relation with no two ordered pairs having the same first element notation. In other words, for each x, there is only one y out. So in the ordered pairs, the x's do not repeat. So this is a function where real x values in the real number set going in and going out are also part of the real number set of y values for such function. And here's another way to describe it. Function x going in, y going out, or x in, f of x going out. Mapping. Synonym for function. Domain. We use sometimes D is used for domain, and sometimes S is used for the range. Then we can also use the function D for domain going in, range going out. Also, a function is a relation or set of ordered pairs in the real number set. For each element x in the domain, there is precisely one element y. So again, that's another definition of a function. For each x going in, there's one y going out, where the x's do not repeat in the ordered pairs. Okay, sequence. Sequence of a function. A function has its domain some or all of the natural numbers. Where we have finite, when the domain consists of a finite number of positive integers. In other words, it has a beginning and an end. Infinite, domain consists of infinite numbers of positive integers. It has no end. So for sum, for all integers where n, some number n, so we're talking about natural numbers here, right? Counting numbers, we count numbers, we start with 1. Of the numbers a sub 1, a sub 2, a to the n are defined by b to the n, b sub n, and c sub n. So if we were to take the sum a sub 1, a sub 2 plus a sub n, we get b, which is a single answer out, which is the sum of all the a's. So if we look at a summation notation from I equal 1 to some limit, some number n, could be 5, could be 100, whatever n is. We have a sub I, it's going to be a1, because that's where it starts. Whatever this number is, that's what it's going to start with here. A1, a2, to whatever this number here is. And so you're going to add all those up, and you get some number b to the n as your answer. Product, for all integers where n is greater than or equal to 1 of the numbers, a1, a2 to a to the n, they're defined by, again, some answer, b sub n or c sub n. You're multiplying a sub 1 times a sub 2 times a sub n, and that equals to some number c sub n. So this number, just like the summation sign is the sum for sum, sigma, then we have the symbol here for multiplying as a product. So instead of adding, you're multiplying these numbers. So where I equals 1 to some number n, a sub I is a times a sub 1 times a sub 2, and then times a sub n equals to some number c. And so we're going to stop here with this instructional video.